All right, 3.2, logarithmic functions. Log functions and expressions. So first we're looking here at log form. In log form, if we would have log base b of x equals y. And make sure when you write your base is smaller, it's a subscript. It's not a full-size b. It's smaller and a little bit underneath the g for log. Like the way an exponent is little and up, the subscript is little and down. So log base b of x equals y. Your Algebra 2 teacher may not have used x and y. Maybe they used a and e. You could ask 3 different Algebra 2 teachers their method of teaching this, and they probably give you 3 slightly different variations. I like x and y because when it gets to graphing, you use x and y. So if you have log base b of x equals y, and you want to turn that into exponential form, the base of the log is going to stay the base. The base is always the base. The base of the log is also the base of the exponent. So base b, and in the log, b is with x, right? So when we go to exponential, x and y are going to trade places. Now it's y's turn to be with b. So it's going to be b raised to the y power, and x is going to have to go over by itself. So equals x.
So why would we just take away the log?
We turned the log into exponential. Because sometimes, like in the example I'm about to give you right now, like evaluate log base 3 of 81. If I asked you to do that without a calculator, I don't know what log base 3 of 81 is just by looking at that problem. But if I turn this into an exponential, I can easily do it without a calculator. So you have to know what is what and where it's going to go. So this is in the log form. So log base b, so the base here is 3, of the argument, in this case x, is the 81, equals y. We don't have a y. We don't know what it is. That's what we're trying to figure out. What is it equal to? So we had to fill in that piece. And then we can turn it into an exponential by using the log base. The base of the log is 3. So that is going to be the base of the exponential. And over here, the y is by itself. So now it's y's turn to have a buddy. So it's going to be 3 to the y equals 81.
So we had to find what y is to get 81.
Yes, so at least it's a familiar form. 3 to the what power equals 81. So you know you're multiplying 3's. So how many times do you need to multiply 3 to get to 81? So you can just go to the side. 3 times 3 will give you 9. So multiply it by 3 again, and then you would get 27. So multiply it by 3 again, and then you would get 81. And then you can just count up how many times you multiplied 3. 4 of them. So to evaluate log base 3 of 81, it is 4. And that's why we would want to do that. And there is also a little note that you need to make about the argument. The argument is, what is x right here? The argument of the log. If you ever see that and it's a negative number, you can stop and say no solution. Because your argument may not be negative. Not be negative. So if it's log base anything of negative 5, you can just say no solution because you cannot do a log of a negative, which would be the same thing as an exponent raised to a power equals a negative. We talked about that yesterday with exponentials. We're not going to get below 0. All right, basic properties. So now I have this table set up. We'll do this table of properties. The first column of the basic properties of logs, these are basic log properties. We're going to look at log base b. meaning, we could put x, log base b of x. B is going to be some number. It could be anything. Or we're also going to look at the common log. The common log always has base 10. And so the button on your calculator that says log, that is common log, and it will automatically do a base 10. If you don't see a base, it's because it's a base 10. And then the natural log. Natural log is ln. It has its own button on the calculator also. Natural log is always base e. So you won't see the e. If it says ln, though, you'll know it's the natural log, and it's a base e. All right, so the first property. If you have log base b, it doesn't matter what the base is. Log with a base of anything of 1, it will always equal 0. The same as the common log of 1 will always equal 0. And the natural log of 1 will equal 0. And that's because of the exponential rule. Like if we look at this as an exponent, b to the 0 power equals 1. Anything raised to the 0 power equals 1. And so on this one, the common log, if we filled in the base 10, because the common log always has base 10, 10 to the 0 power equals 1. Natural log is always base e, so e to the 0 power equals 1, because anything to the 0 power is 1. So if you see any of the logs, when the argument equals 1, you know the outcome is 0. So that's just one of the basic properties of logs. If the argument is 1, then it equals 0.
What does it say before the E?
ln. Yes, most of the time people write ln with a cursive L, because if you do a regular ln, then it looks like a 1. All right, so then the next one is log base b of b equals 1. Log base b, when the argument is b, equals 1. Which is the same as the common log of 10 will equal 1. And the natural log of e will equal 1. So what's happening with this one is if the base and the argument are the same value, that's saying b to the first power equals b. It equals itself. Anything raised to the first power is whatever you started with. So if you have a matching argument and base, that is going to be 1. And 1 equals 1. So on the rest of these, we're proving that the statement is true. So log base b of b is 1, and 1 equals 1. The next one, common log, well, the base of the common log is 10. So log base 10 of 10 equals 1. So you have the 10 right next to the 10. So that tells you it's 1. And 1 equals 1. And the same with the natural log. Natural log is base e. You see the e right next to the e. So that's going to be 1 equals 1. So anytime you see the base and the argument are the same thing, you know that value is 1. So if it's in the middle of a big equation, you could turn that into a 1, and it'll make your problem a lot easier. Okay, so then the next rule or property is if you have log base b of b to the x will equal x. Same as log the common log of 10 to the x will equal x. And the natural log of e to the x will equal x. So this property of logarithms is if you have an exponent inside a log, you can move it. Because that looks really complicated, so we don't like that with the exponent inside. As you can see, log base b of b, and so you want that to be 1, but you have this exponent here. So we can take the exponent, so we don't like it there, let's move it in front and put it right here. So if we do that, then we can see we have log base b of b, log base b of b. We know that is 1. And then we bring down that x that we moved out front. It's x times log base b of b. So it's x times 1 equals x. And x times 1 is just x equals x. So the rule here is the exponent can get moved in front. If that way, if you can simplify something after you move the exponent, it makes it available to be simplified down to 1, and then you just have x. So over here, you have the argument raised to a power. Well, we don't like the exponent inside the log, so I'm going to take the exponent, move it to the front, and say times x. Then I have the common log of 10. Well, common log has a base 10. If it has a base 10, and the argument is 10, that's just 1. We learned that in the property right above. And then bring down the x equals x. And yes, x times 1 equals x. So same thing with the natural log. You have an exponent inside your log. We don't want an exponent inside the log. It makes it more complicated. So let's take the exponent and move it out front. So then I have natural log of e. Well, up here in the property above it, I said the natural log of e is just 1. So I'm going to simplify natural log of e and call that 1. And then I have the x in front. And that equals x. Does that make sense? We're good? Okay, so then the last property is b raised to the power of log base b of x. And that will end up equaling x. We're going to prove that that equals x. And then 10 raised to the power of log base b of x will equal x. And the natural log, oops, I put that in the wrong spot. We'll just ignore that right there. Didn't mean to write that. That's supposed to be e.
Like, what are we learning this for?
So whenever you get an equation with logs and exponentials.
With like numbers?
These are just the properties. So you know that you can do this, that you know you can move the exponent. If you need to solve an equation with all of this in it, you need to know the steps you can take to figure out the value. So this one would be e raised to ln x will equal x. Okay, so the first one, we have, so this is an exponential. This is not log. This is an exponential, but there's a log in the exponent. And that looks really messy and complicated. So we can use this same rule anytime a log is involved. You can take the exponent and move it to the front.
How are we supposed to remember all of this?
Practice. So log base b of x, and then we have a b there already, equals x. Okay, so log base b of xb. So if I just look at the argument, just the xb, That's multiplying. X times b, b times x. It doesn't matter which order. Like if I said 2 times 3 or 3 times 2, it doesn't matter which order I say the numbers. They're both 6, right? So x times b is the same as b times x. So if I could rearrange this if I wanted to and write it as log base b of bx will equal x. Then you can see you have log base b right next to the argument b. So that part, just like in the one above, is going to be 1. And then bring down the rest of it, which is x equals x. And 1 times x equals x. That's true. Now this step right here is not a mandatory step. If you notice that on this step, that you had log base b and you had a b in the argument, you could cancel it right there and just leave the x. But I rearranged it so I could show you that it matches the same as it matched on the other ones. All right, so the next one, again, it's the same process. We have an exponential, and there's a log in the exponential. So we're going to take the exponent and move it in front. So now it is log base, oh, I wrote base b. That's just supposed to be log x. That b is not supposed to be there. That one was just log x. So log x, and then we add 10 times 10 equals x. And I know that the base of the common log is 10. And I can rearrange, instead of x times 10, I could say 10x. So I could write this as log base 10 of 10x equals x. So you see you have log base 10 of 10. Base 10 of 10 is just 1. So x equals x. And then one more time with the natural log, you can take the exponent, move it in front. So ln of x times e equals x. So ln of ex equals x, because I can switch the order here. Then I have the natural log of e, and we've already established that the natural log of e is just 1.
So what's the exponent for the middle one? The log?
Log of x.
Oh, so there's nothing. Why do we cross out the L and EX?
The natural log of e, because ln of e, come back up here, ln, the base of the natural log is e. So we have base e of e. So it's the same thing we did here and here. The base of natural log is e. And I recommend when you're doing these problems, for the common log and the natural log, to go ahead and write it in there. Even though it's understood and you don't have to, you'll notice, you're more likely to notice that you can cancel it whenever you see it there than if you just go with the fact that it's an understood e.